Okay, so as we've already discussed in the previous video, electrovalent bonds and covalent bonds, the major difference between them is that in electrovalent bonds, there is a distinct transfer of electrons from one to the other, one element to the other, and therefore it's always between a metallic element and a non-metallic element. Covalent bond, meanwhile, there's no transfer of electrons. All it is sharing, as we have written over here. In this, two atoms will combine and they will be non-metallic elements, both of them. Uh, they both are going to contribute a certain number of electrons such that both of them will gain stability at the same time, and both the electrons are shared by both. The most common example of a covalent bond, simplest one, is the H2 bond, a bond between two hydrogen molecules. So I'm just going to show it over here. This is the nucleus of H and the first shell. One electron here, and of course the second one, same thing here. So electronic configuration here is basically 1, and as we discussed, it needs to complete its valence electron and satisfy either the octet rule or the duplet rule. It's quite clear here that hydrogen will complete the duplet rule to become stable. So both of them, their electronic configuration needs to be just 2, which means that both of them need to add one electron to their valence shell. Now both of them have 1 each, so in order to satisfy this and make both of them stable, what happens is that these two come together. Just going to show it here. Put 1 electron here. This is the second hydrogen atom. And the second one overlaps. So both the electrons are shared by both of them. So what happens is that the atoms come together and share the electrons. So both the electrons are there revolving in both of the atoms. As a result, this one's electronic configuration is 2, this one's electronic configuration is 2, and so both of them are stable. This is, of course, the structure of hydrogen gas, H2. 2, of course, because the 2 atoms combining to make 1 molecule. And you will learn this later in another chapter. This 2 is called the atomicity of the gas. Not important right now though. Now, covalent bonds are actually the true bonds. Another example of covalent bond would be the oxygen molecule. I'm just going to clear this up. Another example is O2, oxygen. So I'm just going to show that quickly here. So oxygen electronic configuration is 2, 6. Now this is the nucleus, valence shell here, the second one. Okay, so it's 2, 6. So I'm just gonna make a different color so you can make a difference. 2, and you're gonna have 4 over here. the other two will actually come over here. These are the ones which will be shared. I'm just going to make the other atoms electrons a different color so you can again make out the difference. First shell has two. Can't make out the difference really. I'm just going to make it darker. Okay. Again, 4 of them will be on this side, and then 2 of them, the ones that will be shared over here. Now you can see from its configuration that both of these are 2,6, and to just satisfy the octet rule, they both need two electrons each. So 2 electrons from each atom are going to be shared. So in all there'll be 4 electrons being shared. So as a result, these 2 green electrons will come into this shell. So this one's configuration becomes 2,8, so it's satisfied. And at the same time, the 2 yellow ones are also going to be shared by the other atom, 2,8 again. There are other more complex examples, some of them being water and ammonia, and also methane, which is hydrocarbon. So I'm just going to quickly draw the structure for that. Just going to this out. Methane's formula is CH4. Okay, CH4. Now, electronic configuration of H is of course 1. C is 2, 4. So this needs 4E to complete its octet, while this needs 1E to complete its triplet. So what happens is that 4 of these combine with 1 of these. You have the carbon in the middle, and the 4H surrounds it on all 4 sides. So there is 1 electron, hydrogens here, 1 here, 1 here, 1 here. And at the same time, carbon also has just 4 electrons all around. So this is shared with this is shared with this. These 2 are a pair, these 2 are a pair. So you can see all the 4 hydrogens are complete. All of them have 2 electrons in their valence shell, while carbon has 1, 2 over here, 3, 4, 5, 6, and 7, 8. So both of them are satisfied at the same time. I'm also going to quickly draw the structure for ammonia, because that's going to come in use for the next topic as well. That's coordinate bond. So this is ammonia. It's NH3. 1 electron here, 1 electron here, 1 electron here. N has 5 in its valence shell, so there's 1 here, 1 here, 1 here, and there are 2 left over here. You call this pair of electrons the lone pair, because they do not take part in the covalent bond. It's only these 3 pairs. Now in the next video we're going to cover coordinate bond and finish up the chapter, and also look at some of the properties of all these 3 bonds.